Hello guys, this is again a very good problem from chapter 4 Pathfinder. It's also based on center of mass and some work energy theorem concept. Okay, some little circular motion part. If you have solved Pathfinder questions NLM, you can be very um, this would hardly take about 5 minutes. Like okay, so this number 14. Okay, please give it a thorough reading and give your thought about this question, and if have any doubt, then you can see my video, and if you got the answer, then also see the solution. Okay, it is said that a block of mass capital M can slide without friction on a horizontal floor. A small block of mass small m is suspended by a light inextendable cord of length L from a hanger fixed at the top of the vertical pole, mounted on the block so that the ball can swing freely in a vertical plane. The ball is released from a horizontal position as shown. Find the maximum tensile force in the string during the subsequent motion. Okay, so let's go into the solution. So it is given that the floor, it is frictionless. Okay, it is frictionless, so there is no horizontal force given. So and it is said that the this ball, the small m, it is released it is released. Okay, and so how to approach this question? Okay, you are first, we have to see that as there is no horizontal force in it. Okay, means that as there is no friction in it and all, so we can first, the thought will come about the momentum conservation. Okay, so let's see that as there this is the hanger and this is the cord which is attached with a smaller mass. Okay, so so there will be a tension force acting on the small mass, and there will be an there will be an equal and opposite force in a tension force. So this component, let's say this is theta, so this t sine theta component will make the block move to the right. Okay, even you can like think the velocities in any direction of the block, but yeah, you need like as a general, as you know the forces and all acting, so you can be sure that it is moving on the right. Okay, as the small mass is released. Okay, so let's give some velocities, like determine the velocities and all. Let's say the velocity of this block is v1. Okay, and v2 of this small block, which is with respect to the block. Okay, with respect to the block, so we know that velocity of ball with respect to ground is equal to the velocity of ball with respect to the block plus velocity of block with respect to the ground frame. Okay, so velocity of block with respect to ground frame, it is this minus v2 plus v1. So also I can write that velocity of ball with respect to ground frame, it is v2 minus v1 in the leftward. Okay, I can say that. So if you like if you come in the frame of this block, you will see that the small mass is performing a circular motion. Okay, as it is attached with the cord and all. Okay, so you can feel that it will have a circular motion about this part. Okay, about this hinge part. Okay, so it will be like a simple pendulum kind of um, in this block frame. Okay, so it performs circular motion. Okay, so I can let's say there is theta. Okay, so this there will be a tension on this ball, and there will be a pseudo force as we come in the non-inertial frame. So it is small m into acceleration of this block. Okay, so how to find this acceleration of this block? As you can see that the component uh, in the ground frame, the t sine theta the sine theta component of tension will give the necessary acceleration of this block. Okay, so I write that acceleration of the um, block is t sine theta by its mass. Okay, so which is I'm denoted by a1. So the pseudo force will be m into a1, so that along the string it will t minus mg cos theta plus this component m a1 sin theta equal to um, centripetal acceleration. Okay, m v square by l, or as we are in the relative frame, so it is m v2 square by l. Okay, I guess you got that how it is coming v2. So t equal to mg cos theta plus mv2 square by l whole divided by 1 plus small m by capital M sin square theta. Okay, so in this question we need to find the t max, right? So if we want the t max, we want the numerator to be maximum, also that the denominator should be minimum, right? So for cos theta to be maximum, the theta can the cos theta will be 1, that means theta is 0 degree, or this to be minimum means that this portion to be minimum means sin theta should be minimum, means sin theta minimum when like theta is 0. Okay, which is 0, and cos theta maximum means cos theta equal to 1, right? So which is possible at theta equal to 0, right? So tension will, um, as by intuition only you can say that tension will be maximum at the bottom part. Okay, um, so for T max it is equal to mg plus m v2 square by l. Okay, wrote that. In the ground frame we are coming to find the value of as we need for T max we have unknown only v2, right? So we need to find v2, right? So there is like two method, like using work energy theorem. Okay, you can come in the ground frame, or you can do this problem in the center of mass frame. I guess center of mass frame is quite more like less calculative and all, but you can solve it in center of mass frame. I'm doing in ground frame. So by momentum conservation, that is in x direction. Okay, in x direction momentum conservation, it is mv1 minus m v2 minus v1 equal to 0. So yeah, as we need to find the tension maximum, which is at theta equal to 0, so we wrote this part. Okay, and in the ground frame by work energy theorem, mgl is equal to gain in kinetic energy. So kinetic energy gain in the block, and the small mass is written here in the ground frame. And so by solving this 1, 2 and 3 equation, we get v2 and t max, substituting in this, and we will get t. I request you to like solve this not in ground frame but in the COM frame. Okay, in the COM frame it will be quite efficient, and they're less calculative. So yeah, you can give it a try using center of mass COM frame and proceed. Okay, thank you.